Good evening all. Last class we have completed the rate of change. This class we will start increasing and decreasing functions. First we will see what is the definition of increasing and decreasing functions. So what is definition given here? We have to consider I be an open interval. I am going to take it as an I is an interval. It is an open interval and contained in the domain of real valued function f. Then f is said to be increasing function means in the interval f is an increasing function in the interval I means we have to take 2 points x1 comma x2 in this interval. We have to take the points x1 comma x2 in this open interval I. Then we have to find the value of f of x1 and f of x2, that is the value of the function at x1 and x2 we have to find. If f of x1 is less than or equal to f of x2 means we can say that the function is increasing function. Similarly, what is strictly increasing means the same x1 x2 we have to take. X1 is less than x2 we have to take in the interval I. If f of x1 is less than f of x2 means we can say that is strictly increasing function. So the difference between increasing and strictly increasing is f of x1 is less than or equal to f of x2 mean that is increasing function. F of x1 is less than f of x2 mean that is strictly increasing function. Similarly, decreasing function also we have to take x1 x2 we have to take that x1 less than x2, but f of x1 value is greater than or equal to f of x2 means we can say that that is decreasing function. So f is decreasing function. Suppose f of x1 is greater than f of x2 means we can say that it is strictly decreasing function. Clear? This is the definition of increasing function, strictly increasing function, decreasing function and strictly decreasing function. Now we will see some examples for increasing function, decreasing function. We will see some graphs. So consider this graph. For example, this is my y-axis, this is my x-axis. So if I am taking a graph like that, this is the graph. So this graph is an increasing function. So what is strictly increasing function? Strictly increasing function means, example, this is the graph for strictly increasing function. Similarly, this is strictly increasing. Similarly, what is decreasing function means this one, certain point it is coming down. So this is called decreasing function graph. Strictly decreasing function means this is strictly decreasing function graph. So we can write we can find one more graph also, that is neither increasing nor decreasing. That graph we can take it as like this graph. This graph are called neither increasing because from starting from here to this point it is increasing. From here to here it is decreasing. Again it is starting to increase from here. So the whole interval, for example, this interval a to b means the interval a to b, it is neither increasing nor decreasing because some points it is increasing, some point it is decreasing. So this graph is example for neither increasing nor decreasing, neither increasing nor decreasing. Next we will see theorem to check the using this derivatives, we will check whether the function is increasing or decreasing or constant function. We will see now. So each and every time we cannot use the definition of increasing, decreasing. We cannot check that whether function is increasing or not, decreasing or not. So we are going to use the concept of derivative. So by the theorem 1 we will get to know. So what is given means f is a continuous function. F is a continuous function on the interval a comma b and closed interval a comma b and differentiable and differentiable on open interval a comma b. So the function f is continuous on closed interval a comma b and is differentiable on the open interval a comma b. Then if my first f is increasing, when f is increasing in the interval closed interval a comma b means we can say that f dash of x is greater than 0 for each, not for all, not for each value of x comma b. So for each x belongs to the open interval a comma b. If we are substituting the point, if at any point we can take x in the interval, substituting in the first derivative of the function f, that should be greater than 0. If it is greater than 0 means we can say that that function is increasing. Similarly, f is decreasing. When f is decreasing in the interval a comma b means, close interval a comma b means f dash of x is less than 0. F dash of x must be less than 0 for each x belongs to the open interval a comma b. If you have taken the values a comma b, substituting in the f dash of x, if you are getting it is less than 0 means that is decreasing. If you are getting greater than 0 means that is increasing. What about strictly increasing? What about strictly increasing? Strictly increasing and strictly decreasing, same definition. If you have taken this open interval, if you, instead of this closed interval, we can taking the open interval means we can say that that is strictly increasing. If you have taken the second case open interval a comma b means we can say that that is strictly decreasing. So this is definition of strictly increasing and decreasing using the first derivative test. This using the derivatives f dash of x. So now we will move to the problems. Functions will be given. We have to identify whether the function is increasing or decreasing or strictly increasing, strictly decreasing, and at which interval it is increasing, at which interval it is decreasing. All these things we will see now. 6.2 first question. So that the function given by f of x equal to, so the function f of x given that 3x plus 17, f of x equal to 3x plus 17 is strictly increasing on the real numbers, or we have to prove strictly increasing on the real numbers, or we have to prove. So we will use the theorem 1 now. What is theorem 1? If f dash of x is greater than 0 means we can say that f is increasing function. So I am going to use that now. So see that now. So what is the value of f dash of x? F dash of x equal differentiation of 3x equal to 3x plus 7 equal to 3 will come. So now we know that we can substitute the values. F dash of x is 3. So if the f dash of x is greater than 0 for all the classes, for all the cases, for all x belongs to the real number r. So therefore I can say f is strictly increasing on the real number r. Now question number 2, same model. F of x equal to e power 2x. F of x equal to e power 2x. Now what is the value of f dash of x? F dash of x equal to e power 2x into 2. So this question this question also we have to prove that it is strictly increasing on the real number. So we know that e power x always positive, 2 is always positive. So f dash of x also always greater than 0 for all the value of x belongs to r. So what I can conclude, therefore f is strictly increasing on the real number r. Clear? Now question number 3. So question number 3, what is given? F of x equal to sin x. F of x equals to sin x. So the sin x I need to show that first case it is strictly increasing in the interval, open interval 0 to pi by 2. So first I will show it is strictly increasing in the interval. Clear? So now what is the value of f of x? So f of x equal to sin x. Now differentiating f dash of x, f dash of x equal to cos x. Now I am going to take it as this f dash of x equal to 0. So if f dash of x equal to 0, this implies cos x equal to 0 will come. So cos x equal to 0 means what is the value of x? X equal to 2n plus 1 pi by 2. So 2n plus 1 pi by 2 means if you are taking here it is n value equal to z. So what are the values x will satisfy? X at n equal to 0 means we will get pi by 2. N equal to 1 means 2 plus 1 3 pi by 2 will come. N equal to 1. If we are taking n equal to 2 means we will get 5 pi by 2 etc. So these values cos will get 0. So now our interval is given that 0 to pi by 2. So before that, if you are taking n equal to minus 1 means 2 into minus 1 minus 2 plus 1 minus 1. So minus pi by 2 will come. So we are taking negative also minus pi by 2. So we know that clearly the interval is 0 to pi by 2. So what we have to show, that means we have to take the cos x is, we have to show that only there is no intervals in this interval. So clearly 0 to pi by 2 is the only point. So we know that clearly f dash of x means that is cos x. Cos x is always greater than 0, because since cos x is positive in first quadrant, cos x is positive in first quadrant. So f dash of x greater than 0 means f is strictly increasing, f is strictly increasing in the interval, open interval 0 to pi by 2. Now second case. So second case, we have to prove that strictly decreasing in the interval pi by 2 to pi. So same, f of x equal to sin x, f dash of x equal to differentiation of sin x equal to cos x. If you are taking cos x equal to 0 also, we will get the intervals, that is x values are, if f dash of x equal to 0, this implies x values are minus pi by 2, plus pi by 2, 3 pi by 2, like that we will get. So we have to take this whole interval, there is no partition in this interval. So clearly we can say that f dash of x is less than 0, because our f dash of x is cos x. This cos function is negative on the second quadrant, sorry, second quadrant. Cos is positive on first quadrant, second quadrant negative, third quadrant negative, fourth quadrant positive. So second quadrant also negative, third quadrant also negative. Our interval is second quadrant, so cos is negative. So we can write that since cos x is negative in second quadrant, cos x is negative in second quadrant, therefore f is strictly decreasing on the interval, open interval pi by 2 to pi. Clear? Now question C. So what is given? Neither increasing nor decreasing on 0 to pi. The same sin x, we need to show that neither increasing. So neither increasing nor decreasing on the interval 0 to pi. So we know that clearly f of x is strictly increasing on interval 0 to pi by 2, and same f of x is strictly decreasing on the interval pi by 2 to pi. So clearly we can write that this is strictly increasing on some partition, strictly decreasing on some partition. So therefore f of x is neither increasing nor decreasing in the whole interval 0 to pi. If it is increasing means at the whole interval 0 to pi it must increase, or if it is decreasing means the whole interval 0 to pi it must decrease. But what is given here, it is increasing on certain partition and decreasing on certain partition. So clearly it is neither increasing nor decreasing. Actually, what is the graph of sin x? From the graph of sin x we can identify easily. This is 0, this is our pi. So it is 0 to pi by 2, the graph is rising, that is increasing. Pi by 2 to pi, the graph is coming down, that is decreasing. So clearly 0 to pi it is neither increasing nor decreasing, because it increases from certain point to certain point, and or increases in certain interval, and it is decreases from certain point to certain point, or decreases from decrease in the certain interval. So it is neither increasing nor decreasing. Now question number 4. So question number 4, what is given? Find the intervals in which the function f is given by f of x. So f of x equal to 2x square minus 3x. So we are going to find the interval where it is strictly increasing and where it is strictly decreasing. We have to identify. So to identify that, what we have to do means we have to find we have to use the theorem 1. So what is f dash of x differential with respect to x? F dash of x equal to 4 times x minus 3. Next, what we have to do means we have to f dash of x equal to, we have to equate the f dash of x equal to 0. If f dash of x equal to 0, this implies we will get 4x minus 3 equal to 0. So 4x minus 3 equal to 0 means x value equal to 3 by 4. X equal to 3 by 4. So the number line will be splitted into two interval, minus infinity to plus infinity number line will be splitted by the point 3 by 4. So the intervals are minus infinity to open interval 3 by 4 and open interval 3 by 4 to infinity. So these are the two intervals. Now we will find in this interval what about this function, in this interval what about this function. Now we will draw the table. From the table we can identify increasing or decreasing. So first column will be intervals. Second column will be point. Third column will be sine of f dash of x. Fourth column will be strictly increasing or strictly decreasing. Now what is the first interval? We will take that minus infinity to minus infinity to 3 by 4. Open interval minus infinity to 3 by 4. In between them I can take any point. I am taking 0. So sine of f dash of x value I have here. Substitute x equal to 0 here. I will get minus 3. So minus 3 means negative. Negative means we can say that strictly decreasing because f dash of x is less than 0 in this interval. So strictly decreasing. Next second interval I am taking 3 by 4 comma infinity. 3 by 4 comma infinity means immediately I can take 1. So in this interval I can take 1. Substitute x equal to 1 here. We will get 4 minus 3. If plus 1 will come. So plus 1 means positive. So f dash of x is greater than 0 in this interval. So it is strictly increasing. So we can conclude that f of x is strictly decreasing on minus infinity to 3 by 4. That we can write as answer. F is strictly increasing on the interval minus infinity to 3 by 4 and strictly decreasing on the interval 3 by 4 to infinity. Now we will see this diagrammatically. Actually I am going to show this diagram and I am going to show that this minus infinity to 3 by 4 it is increasing, strictly increasing, and 3 by 4 to infinity it is strictly decreasing. I am going to show now. Look at this diagram. Now see the graph of this function. It is given that y equal to 2 times x square minus 3x. So this is the graph given for us. So look at this graph. From minus infinity to, if you are extending the graph to minus infinity means it is decreasing. Minus infinity to certain point it is decreasing. So that certain point is this one. What is that? 0.75. If I are converting into fraction means that is 3 by 4. So minus infinity to the left side minus infinity to this 3 point 0.75, that is 3 by 4, it is strictly decreasing. After 0.75, right side of 0.5, the graph started to increase up to infinity, which is given here. Clear? Okay, now we'll go to the next question. Now question number 5. So what is given here? F of x equal to, here it is given cubic polynomial f of x equal to 2x cube minus 3x square minus 36x plus 7 is given. So here also we have to find at which interval it is strictly decreasing and strictly increasing. So as similar last question, we have to find the f dash of x, that is 6 times x square minus 6x minus 36. So what we can do, we can take 6 as common. So remaining will be x square minus x minus 6 will be there. So we can factorize this also. Factorizing means what will come? X minus 3 into x minus 2 or plus 2 will come. So multiplying these two, we will get minus 6. Adding these two, we will get minus 6. So these are the f dash of x value. So now what we have to find? We have to find the interval points. To find interval points, we have to find f dash of x equal to 0. For what value of x? F dash of x equal to 0. So if f dash of x equal to 0, this implies x minus 3, that is 6 into x minus 3 into x plus 2 equal to 0. This implies x equal to minus 2 and plus 3. So then my number line will be splitted. Minus infinity to plus infinity is splitted as minus infinity to minus 2, minus 2 to 3, 3 to infinity. So total intervals, 3 intervals will come. The intervals are, what are they? Minus infinity to minus 2, minus 2 to 3, and 3 to infinity. Now we will find the sign of f dash of x in these intervals. So as it is, first column will be intervals, second column will be points, third column will be sign of f dash of x, fourth column will be strictly increasing or strictly decreasing. Clear? So now we will find that. So take the first interval, minus infinity to minus 2. So substitute any point in this interval. I can take minus 3. If I am substituting minus 3 in f dash of x, that is f dash of x means what will come? First one 6, minus 3 means it is minus 6, minus 3 means again it is minus 1. So positive into negative we will get positive. So positive means we can find that it is strictly increasing. Next, second interval, minus 2 to 3. Minus 2 to 3, easily I can take it as 0. Substituting 0 means 6 into 0 means minus 3. Substituting x equal to 0 means plus 2. So positive into positive, we will get negative. Negative means strictly decreasing. Next, the third interval, 3 to infinity, I can take positive 4. So positive 4 means 6 into, substitute x equal to 4 means 1 will come. X equal to 4 means 6 will come. So positive into positive will come. So strictly increasing. So we can say that f of x is strictly increasing on minus infinity to minus 2, strictly decreasing on minus 2 to 3, strictly increasing on 3 to infinity. That we have to write finally. That is, f is strictly increasing on, what are the intervals? Minus infinity to minus 2 and 3 to infinity. Similarly, f is strictly decreasing on only interval minus 2 to 3. Now we will see this diagrammatically. Now what is the given function here? Y equal to 2 times x cube y equal to 2 times x cube minus 3x square minus 36x plus 7. This is the given question. Now see that 2x cube minus 3x square minus 36x plus 7. So you see that the graph is steadily increasing. The graph is increasing up to which point? Minus 2. Next minus 2 2 started to decrease, minus 2 2 it is decreasing up to 3. So the points we can see that minus 2 comma 51 3 comma minus 100 is minus infinity to minus 2, it is steadily increasing. Minus 2 to 3 it is steadily decreasing. Again 3 to infinity it is steadily increasing. That now we are seeing by diagrammatically. In previous now we are seeing diagrammatically it is increasing steadily increasing. Then minus 2 to 3 it is steadily decreasing. Then 3 to infinity it is steadily increasing. Now we have used the theorem we have seen. Now we are showing by diagrammatically. It is not possible to draw graph always, that's why we are using the theorem. Clear? Thank you. Remaining questions we will see in next class.